Hey everyone, and welcome back to The Explainer. Today we're literally tearing apart a fascinating piece of short-form media. We are going to deconstruct a highly effective 60-second script that's designed to teach viewers exactly how to build an Arduino light-sensing project. Now we'll look at the hardware engineering for sure, but we're really going to focus on the anatomy of the script itself, how you can communicate complex technical ideas in literally 1 minute. It's going to be a fun one. Right out of the gate, we get this hook. Control light with your mind? It immediately captures your attention, doesn't it? Why? Well, because it poses a seemingly impossible scenario in the very first frame. It completely challenges reality, kind of forcing you to pause your scrolling and demand an explanation for what you're seeing. It's a fantastic hook.
Okay, let's dive into this dual-track narrative. Here is our agenda. 1. The hook. 2. The hardware setup. 3. Assembly and wiring. 4. The secret code. And finally, 5. The final demo and call to action. To give you a quick roadmap, here is the highly structured 60-second timeline formula at work. The hook takes exactly 0 to 5 seconds. Materials just fly by from 5 to 15 seconds. Assembly gets a super tight 15 seconds. The code gets another 15. And the final demo and call to action wrap up the last 15 seconds. You guys, it is an absolute masterclass in pacing. It sets incredibly clear expectations for how you can teach quickly without losing the audience's focus.
All right, let's kick things off with section 1, the hook, from 0 to 5 seconds.
In these crucial first 5 seconds, the script powerfully engages multiple senses. Visually, we get this awesome close-up of an LED turning on the exact moment a hand passes over the sensor. But on the audio track, we hear a really intriguing rhetorical prompt. What if I told you that you can control light without even touching a switch? It's a brilliant juxtaposition, right? You see a captivating action while simultaneously hearing a thought-provoking question. It perfectly primes you for the engineering lesson that's about to hit.
Moving on to section 2, the hardware setup, covering the 5 to 15 second mark.
Now what's really interesting about this slide is how that initial magic trick from the hook is instantly grounded in actual tangible components. We see these rapid-fire cuts of the basic hardware you need, an Arduino, a photoresistor or LDR, a 10K ohm resistor, an LED, and a 220 ohm resistor. The audio calmly assures us you just need an Arduino, a photoresistor, and a few basic components. It instantly demystifies the magic, replacing it with totally accessible engineering.
Notice the relentless forward momentum here. 0 seconds, hook. 5 seconds, materials display. And by 15 seconds, breadboard assembly begins. The script shifts incredibly smoothly from merely gathering materials right into the physical build phase. There's no fluff, no stalling whatsoever. It completely respects your time and keeps your attention totally locked in.
Next up, Section 3, Assembly and Wiring, which takes up the 15 to 30 second block.
For this specific stage, the creator relies on a really smart visual cue, a time-lapse of breadboard wiring. Building a circuit can be meticulous and honestly a bit slow to watch in real time. But by using a fast-paced time-lapse, this complex physical wiring process gets compressed into a highly digestible 15-second format. You see the actual work happening, but you never get bogged down in the minutia.
So the crucial point is what happens while that visual time-lapse plays. The audio drops a vital piece of technical knowledge, the voltage divider. It explains that this is a setup created so the Arduino can read light intensity on an analog pin. Actually, scratch that. It doesn't just explain it, it teaches it. The script doesn't just show you where to plug in the wires. It briefly but accurately clarifies the exact purpose of the LDR circuit. It's literally teaching real electronics theory on the fly.
Down to section 4, the secret code, mapping out the 30 to 45 second mark.
And this brilliantly illustrates a necessary shift in modern hardware projects, contrasting the physical with the digital. Earlier, we had the messy, hands-on, physical reality of the breadboard wiring. Now, the script pivots beautifully to a clean digital execution, a serial monitor capture. It visually reinforces the fact that hardware absolutely needs software to come alive and actually function. We are promised the secret code in the video text. But here's the best part. It's not actually kept a secret. The script bravely reveals the inner workings of the project, displaying the actual standard Arduino code that makes that voltage divider data actionable. It completely empowers the viewer by giving them the exact logic they need to replicate the whole shebang at home.
Let's move to and see how this builds into section 5, the final demo and CTA, rounding out our last 15 seconds.
This is where the script neatly closes the loop on the massive promise it made in the very first 5 seconds. We get a crystal clear cause and effect. The action of turning off the room lights instantly results in the reaction of the project LED lighting up. It visually demonstrates a responsive, working project. It proves the engineering concept and, most importantly, gives the viewer that satisfying payoff they've been waiting for all minute.
But, it doesn't just end with the glowing LED. It signs off with a demand for interaction through a clever, dual-layered call to action. Visually, the on-screen text asks, "Comment which sensor I should test next," while the audio exclaims, "Works perfectly! Subscribe for more engineering projects." It's honestly a masterstroke. The text invites immediate community feedback in the comments, while the audio drives long-term subscription, capturing maximum engagement right as the clock hits exactly 60 seconds.
So, we've reached the end of this 60-second masterclass, and I want to leave you with this question to chew on. How might you adapt this exact 60-second framework, or even this specific sensor setup for your own projects? Whether you're building complex engineering hardware or maybe you're scripting your own quick-hit educational content, this dual-track structure of visual pacing and targeted audio explanations is incredibly powerful. Think about how you can use this blueprint to clearly explain your next big idea. Thanks so much for joining me on this explainer. Keep building, keep learning, and I'll catch you next time.